Jagdish sir, are you in line? Shall we start the session now, sir? Professor Jagdish sir. Jagdish sir, are you in line? Line
Morning, sir. Am I audible? Hello.
Yes, you're audible, sir.
Thank you, sir.
Sir, audible, sir. Sir,
Yes, sir. Yes,
sir.
sir.
Jagdish
Please,
sir.
please.
Okay. Thank you. Well, good morning to one and all present in the meeting. I heartily welcome the Dr. Jagdishan is working as professor of civil engineering in Coimbatore Institute of Technology to convene this session. Dear participants, so we have due to some inconvenience, the speaker and the topic both are changed for this session. So the present guest lecturer is Dr. Jagdish, and his topic is processing techniques required for enhancement of pozzolanic materials. Processing techniques required for enhancement of pozzolanic materials. This is the topic for this session. So I am very happy to introduce Dr. P. Jagdish, who is now working as Professor of Civil Engineering in Coimbatore Institute of Technology in Coimbatore. I wish to give a brief introduction about the resource person. So he has completed his Civil Engineering in Government College of Engineering, Salem in the year 2008. After that, he completed his ME Structural Engineering in Coimbatore Institute of Technology in the year 2012. Then he has been awarded PhD, Anna University, Chennai. So during graduation, he was selected as a best civil engineering student across the country, one of the best civil engineering students across the country, and he has attended 4 weeks training program conducted by IIT Kanpur, and he has submitted 4 international projects and national projects in different departments like Department of Nanotechnology, Science Engineering Research Center, ISRO, etc. He has worked in construction companies also like Cam in India Limited and SR Construction India Private Limited in different levels. Because of his interest, he has completed his MBA in Infrastructure Management from Anna University of Technology, Coimbatore in the year 2011. He joined his alma mater as a faculty in the year 2012. Then he After that, he joined in Surya Engineering College as a faculty in the year 2014. In the same year, he joined. Then he joined in as a teaching faculty in Coimbatore Institute of Technology, and now he's working there. Still date, he's working there. He developed many laboratories. While he was working in Surya Engineering College, he developed many laboratories and involved in many construction projects. So he published papers in 15 national and international journals, and also he published papers, 10 number of papers in national and international conferences also. He is a reviewer for some international research publications like Periodica Polytechnica, Civil Engineering, Construction and Building Materials Journal of Earth Science and Engineering. He guides his students to win first prize in INSDOC in 2020. He has organized many international and national conferences, faculty development programs, short-term courses, and workshops under sponsorships of AICTE, TechU, SCRB, and UGC, etc. He has chaired large number of seminars and conferences also. He is a member in various professional bodies like Institution of Valuers and Institution of India, etc. So with this, I stop my speech and hand over the session to Dr. P. Jagdish to deliver the guest lecture on processing techniques required for enhancement of pozzolanic materials. Thank you, one and all. Now I invite Dr. Jagdish to deliver his address. Thank you, Professor and other participants.
Yeah, thank you, sir. Thank you for such a wonderful introduction about me. Even I hear such a wonderful introduction about me for a long time. Sir, thank you, everyone. Just a second, I will start sharing my screen. I hope my screen is visible. So my screen is visible to everyone. Sir, I think.
No, sir. No, sir.
Yeah, thank you, sir. A very good morning to one and all present on this 1 week AICTE training and learning academy and online faculty program on recent innovations in concrete technology, sponsored by AICTE and organized by Department of Civil Engineering, Shakti Polytechnic College, Erode. I like to appreciate the effort made by convener Mr. K.R. Palaniswamy, head of the Department of Civil Engineering, co-coordinators Mr. R. Parthiban, senior lecturer, and organizing committee members for organizing such a wonderful faculty development program on recent innovation in concrete technology, which is needed during this pandemic situation. Myself, Dr. P. Jagdish, working as an assistant professor in Department of Civil Engineering. I think most of audience are from civil engineering background, and they are doing research in the field relevant to civil engineering. The most of researchers across our civil engineering community choose a topic on a material replacement in either cement or in mortar or in concrete, because it is easily understandable. The experiments are well known to everyone. The equipments are available, and materials which are used for replacement are available locally as a cheap one. The second most material consumed by human next to water is concrete. Hence, that concrete plays such a huge role in our day-to-day life. Construction industries are making such a dense concrete forest across the globe. One of the costlier material in concrete is a cement, which varies between 30 to 40% in overall cost of concrete making. And, hence, if you make a small change in cement, it makes a large variation not only in properties of concrete, whatever you are making, but also in the cost of concrete, it plays a major role. Apart from those environmental benefits like reduction in CO2 emission, natural destructions, those things and all. Therefore, it becomes a focus point for most of researchers to work on replacement of a cement. The material which we replace the cement, what we call it as a supplementary cementitious material or admixtures. Sometimes what we call it as sometimes those materials are in pozzolanic in nature also. As a faculty, we are still want to know what is the difference between supplementary cementitious material and admixtures. The admixtures, the name itself says that these admixtures plays a vital role when you add with respect to your concrete or mortar or wherever it may be we are using. It will play a significant role in enhancing the properties of your concrete or the environmental which they are present. But if you take your supplementary cementitious material, your what we call it as again an admixture, mineral admixtures. Here, some part of those material goes for a larger substitution. Even those things plays a vital role in not only in increasing the properties, they will maintain the level of properties, what we call it as your supplementary cementitious material. Hence, we can differentiate those things clearly. Okay, then I'm here with you to discuss a few topics which are related to this material whose are pozzolanic in nature. I think you know the name why it came as a pozzolon and where it belongs as a basic to civil. We know all those things. I'm not here with you to discuss the topic which is already spoken by several speakers or already known topic. The topic which I'm going to discuss is a interdepartmental one. If a combination of several engineering department like mechanical, chemical, and material science, if they work together, we will have a possibility of enhancing the property of cementitious or binding material. The topic which I'm going to discuss for next 75 to 80 minutes is processing techniques required for enhancement of pozzolanic material. One of the research states that revenue happening around pozzolana is 90 billion US dollars by the end of 2025. Kindly remember that it is a growing factor in construction sector where people are nowadays concentrating on more about this kind of pozzolanic material to enhance the cement properties or concrete property or mortar property. By the way, they want to reduce the environmental related effect and also reduce the cost of concrete. As per the per capita consumption of cement in India is almost 195 kg, which is far less than world average of 450 kg. And if you take China, the consumption capacity is almost 1000 kg per person. Okay, I think my voice is clear to everyone. If you take cement industry, the cement industry growth rate is approximately will take as 1.2 times the GDP growth rate of country. Hence, kindly think of that the growth of cement industry plays such a vital role in economical thing of a particular country. India is second largest producer and consumer of cement, which having an installed capacity of 425 million tons from 575 cement industries. These 575 cement industries, which will include almost 260 larger scale industry and balance is going for small scale related things which associated with the cement production. Okay. Then I think you know there are two processes involving in the production of cement. One is wet process and another one is a dry process. The wet process requires 0.28 ton of coal and 110 kilowatt of power to manufacture 1 ton of cement, whereas dry process requires slightly lesser amount of coal, that is 0.18 ton of coal and 100 kilowatt of power to produce 1 ton of cement. If you take in India, the major installed capacity in cement manufacture is dry process alone. If you take, if you see this picture, it shows that the production rate of cement across global and in Indian scenario from 2013 to 2018. Since 2019 process is going on, I have produced the chart where you can see there is an increase in cement production across a global range from 4,000 million ton to 4,200 million ton, whereas in Indian scenario, it is increased from 260 to 290 million ton. Okay, it's going rapidly on higher state. If you see this second picture, it shows the top 10 countries which were producing the cement across the globe. If you see, the China is the leading producer of the cement, and India is the second largest producer next to China. China is approximately producing half amount of cement across the globe, and it is approximately equal to 8.2 times the cement producing by India. That is, if you take the average cement production across India is 280, then it is approximately 8 into 28 is the China's cement production. Across globe, almost 159 countries are producing cement from 196 countries. 95% of total energy in cement industry is going for this grinding and burning thing. Think you know the terms for grinding. Grinding is nothing but we are making your clinker material or your whatever input ingredients. You will make to grind it using a small number of balls and using various instruments like rotatory grinding is there, centrifugal grinding method is there. We are using several methods depending upon your industry. We are going for several method, recommending method for grinding thing and burning of these calcareous minerals to form clinker thing. Okay, and as you know, the 99% of installed capacity in India employs dry process since it will consume lesser amount of coal and power. Okay, cement is third most energy intensive material, which consuming 7% of total global energy usage. Next to steel. Steel industry is steel and aluminum are first two industries which consuming more energy than cement. Okay, if you take this chart, it will shows almost 1.6 ton of. I will show those things on.
Sorry to interrupt. I think
Yeah, yes,
slide
sir.
is okay. Okay, sir. Sorry. Now it is slide was it was not changing. Now it is changed. Sorry.
Okay, okay, no issues, sir. I put a slide as one by one, sir. So one by one word is coming. I think now it is visible for you. It is visible, sir, slide?
Yes, sir. Visible. Visible.
Yeah, thank you, sir. If you see this slide, it shows there are three processes involving production of cement. For production of 1 ton of cement, almost you will get consuming 2 tons of earth, natural minerals. According to World Business Council for Sustainable Development, it says that, as I indicated earlier, every person consumption rate, average consumption rate of cement across global per annum is almost 450 kg. Okay, per consumption rate. Cement plants are spending almost 35 to 50% of total manufacturing cost of cement to meet their energy demands. If you see, for production of every ton of cement, almost 1.65 tons of limestone, which is pure calcareous in nature, and 0.4 ton of clay, and 0.05 ton of gypsum is required. If you take approximately, it will require 2.1 ton of natural resources to produce 1 ton of cement. Can you remember that we are consuming or we are destroying the earth in such a way that to produce every kg of cement, we will consume 2 kg of natural materials. Okay, we are making such an impact to world environment. Worldwide total OPC production almost leads to 7 to 8% of total carbon dioxide production. This 8% of CO2 is splitted several ways that I am going to discuss in upcoming slide, where it goes that 8%. There are two emission of your, I think here itself I am mentioning those energy consumption and CO2 emission from cement production from several references as quoted by Chot and Chen. Even IEA, Indian Energy Efficiency Bureau report, BE report, I have tabulated this thing. If you take raw material quarrying, it will consume only 2% of energy utilized, whereas raw material grinding consuming 26% of energy. And clean fuels is nothing but for burning your natural resources. We are using several fuels from fly ash or some other thing. Okay, which will having energy of almost 35%. For finishing your clinker product, the consumption of energy is 30%, whereas others like packing, transporting, that involves 7%. Therefore, the total energy utilized in terms of joules is nothing but 3530 into 10 power 6 joules per ton of cement. If you play a small role to reduce this energy, you can have almost you can save 30% in cost of production of cement itself. Okay, not only in benefiting the environmental benefit, you can also reduce the energy thing also. Okay, if you came across your carbon dioxide emission, which will say that your quarrying will associate with less than 0.5%, whereas grinding, which will have 1.6%, your fuels, which will have 41%, whereas clinker reaction, what we call it as indirect emission of CO2, that is carbonation of your calcium carbonate and magnesium carbonate, which will emit almost 52.33%. We call it as this is a direct emission. You can't reduce this thing, but you can make the production of this thing as a lesser amount. Then finishing milling thing, which is almost 5%. If you add all those things, it will almost come 1 ton. That what the earlier days, what we call it as every ton of cement will produce almost 1.05 ton of CO2. But due to introduction of this pozzolanic material and efficient burner and grinding techniques are came into picture, this 1050 kg is now it is reduced almost to 700 kg per ton of cement produced. India is having a second lesser emission effort next to Japan with respect of production of cement. Since as per BE report, we are producing CO2 which is next to Japan, having an efficiency of 700 kg per ton of cement. Okay. If you take cement industry, it consumes a large amount of supplementary cementitious material. As I already discussed what is meaning of this supplementary cementitious material and how it differs from your admixtures thing. This supplementary cementitious materials like it consumes 27% of fly ash generated and 100% of slag generated, and still researchers like us, we are looking for more amount of new material where we can look into having a pozzolanic in nature, so that we can still reduce this production of not only in CO2 emission, but also we can reduce the energy consumption also. If you take Indian market, you can see almost 17 varieties of cements are available. These 17 varieties include all PPC, OPC, everything. Okay. If you see this picture on right side where it indicate the CO2 and energy consumption from in global level and in Indian scenario, where you can see it is rapidly increasing the CO2 emission from 4.27 to 4.39 in global level for CO2 production, whereas in Indian scenario it is increased from 0.3 to 0.31 into 10 power 9 tons CO2 is produced, whereas if you take energy consumption, it is increased from 26.1 to 26.87 in global scenario from 2013 to 2017, whereas in Indian scenario, it is increased from 1.8 to 1.86 into 10 power 12 joules. Yeah, rapidly on 5-year phase, due to consumption rate, there is always increase in this CO2 and energy level. So it becomes a vital role where we can play a small role to change ingredients in cement that plays a major role not only in saving the environment but also in cost of that cement production thing, and also we can improve the property of those binding material. If you look into the matter in letter of Kyoto Protocol, and this sustainability term came into picture in all industries, where the term sustainability indicates that with respect to future, we want to keep our environment, our living things, and whatever the possibility for our next generation. Okay. That should be kept available for our next generation. It should be made such a way we want to consume our earth resources. Okay, that's what we call it as sustainability. And then, as per your Kyoto Protocol and earlier several protocols. The sustainability is introduced in industries, especially in the cement industries or cement sector. Hence, one of the step indicates that the eco-efficiency steps in cement industry, which will lead to introduction of supplementary cementitious material and admixtures, which will have several benefits around economy, environment, and social thing, which we consider these three as three pillars for sustainability. If you take pozzolanic materials across global level, I will show several things here, which is widely available in Indian scenario, not only in a global scenario but also in Indian scenario. If you take bagasse ash, if you take 10 ton of sugarcane crushed, which will approximately yield 3 tons of wet bagasse. If you burn every ton of this wet bagasse after drying it, make it drying in a open atmospheric condition, and if you burn it, you can get dry bagasse ash, where if you burn every ton of dry bagasse, or the amount of sugarcane bagasse ash obtained from every ton of sugarcane is almost 65 kg. Okay. Then if you take a fly ash from power sector, you can see almost 150 million tons are available. Rice husk ash and the material which we are obtained by burning rice husk, what we call it as a rice husk ash. Every ton of rice will approximately produce 220 kg of rice husk. Then from sail industry, 3,000 tons of silica fumes are produced in every year. This silica fume consumption is widely accepted in various sectors, not only in cement sector. It will go for several other industries also. Hypo sludge, waste sludge which we obtain from paper industry. Every ton of paper approximately produce 300 kg of hypo sludge. Several studies are also going on this area to introduce this sludge into cement. And a well-known thing, a slag. 1 ton of crude iron will approximately produce 200 to 300 kg of slag. Sometimes what we call it as a GGBFS, that is depending upon process, we obtained a ground granular blast furnace slag, what we call it as a GGBFS. It is obtained from blast furnace. We include those term blast furnace slag also. These kind of materials are lot amount available in Indian scenario. Hence, most of our researchers who are working in this cement sector are interested to work in replacement of these materials. Okay. According to, I want to define what is meaning of a pozzolanic material. According to ASTM C618, a pozzolana is defined as a siliceous ions and aluminous material which in itself possesses little or no cementitious value, but one which in finely divided form and in the presence of moisture, which will chemically react with calcium hydroxide at ordinary temperature to form compounds possessing cementitious property. This cementitious properties is like CSH, that is calcium silicate hydrate, and calcium aluminate silicate hydrate, CaSH, are those cementitious property which will have those binding of aggregate thing. Then when pozzolanic materials are added to cement, the silica present in this material react with the free lime released during the hydration of cement and form additional calcium silicate hydrate as a new hydration product. This additional calcium silicate hydrate gel is less dense in nature. If you come across the proportion of calcium to silica mineral composition in this cementitious material or cement content, it is approximately around 1:2 ratio. I think the 2 days before, a speaker has already spoken about characterization techniques of cementitious material, where he can have you enlightened with the area of those techniques, from which you can understand what is the ratio between calcium and silica, and also the ratio between calcium and aluminum. Those things plays a vital role in the formation of this additional hydration products or new products. Pozzolana's activity refers to both its capacity of binding lime and the rate at which the binding reaction takes place. Reactivity of pozzolans depends upon chemical, mineralogical composition, type, and proportion of activity, active phases, the particles specific area, ratio of lime to pozzolan, water content, curing time, and temperature. Hence, there are several factors which will influence the reactivity of pozzolans. Apart from external factors, the internal factors like physical, chemical, and mineralogical composition and morphological thing plays a vital role. The amorphous structures are more reactive than crystalline ones on account of the higher mobility and the superficial location of their atoms on surface, which with the help of SEM you can identify those kind of nature, and it is confirmed with the help of XRD. Pozzolanic reaction is governed by the active silica and alumina content and the specific surface area of these pozzolans. Silica is responsible for earlier pozzolanic reactions, whereas for longer periods, aluminum content is responsible. Sometimes this particle packing effect of pozzolan, which came into picture. The cement particle size larger than 45 micron meter is difficult to hydrate, and those larger than 75 micron meter could never hydrate completely. It will hydrate partially. It will contribute to strength factor only for a certain period. Fineness and water cement ratio affect the heat of hydration and setting times. If you provided with appropriate particle size distribution, it will reduce the heat of hydration of your pozzolanic material or wherever it will present. Hence, from these things, these two slides, you can say that the definition of pozzolanic material will depending upon or it will based on physical. Physical means the size of particle, the nature of particle, either it may be amorphous or crystallographic in nature, and chemical composition. Chemical composition is how much presence of calcium to silica ratio or calcium to alumina content is there. That is composition, mineralogical composition of those pozzolanic material, and microscopic structures. The microscopic structure, which will include the surface nature, how the topographical of that particular particle and how it is present, whether it is porous in nature or how it is improved its reactivity, those things which will define your pozzolanic material. Hence, what I'm trying to say is the definition of pozzolanic material is slightly depend upon or varied those it is mentioned from code. Reason is nowadays people are working on all those these background to confirm whether it is a pozzolanic in nature or not. Okay. The need for this pozzolanic thing is that, as we mentioned, it will introduce a sustainability to field of our construction or cement industry, and also it reduces the cost of your cement materials, and also it will having several advantages. Those advantages we will discuss on our next topic, that is advantages of pozzolanic material. The first advantage is it will reduce the cost of cement. It introduces sustainability in cement material. It will increase or enhance the property of cement where it present. It is it increases durability or fresh. The property may be like durability, fresh or hardened. Disadvantages and the disadvantages of the pozzolanic material is it will react slowly. That will be first thing. That is, it will take time to react. Then the setting time of this pozzolanic material will be prolonged, or it is higher than the ordinary Portland cement, apart from your PPC thing. That is Portland pozzolanic materials. The setting time is increased. Then one of the advantages is it will reduce the heat of hydration. The pozzolanic material will reduce the heat of hydration, thereby it will reduce the that creep and shrinkage thing. That will be controlled if you introduce a pozzolanic material. Okay. Then the types of pozzolanic material, which will include industrial, agricultural, and infiltration type. Industrial pozzolanic material is like your fly ash, GGBS, slag, silica fume, that goes on like that. If you take agricultural pozzolanic materials, it will include your palm oil fuel ash, rice husk ash, sugarcane bagashi ash. Even nowadays, people working with several new kind of material which is abundantly available in our society thing. Then incineration thing is nothing but nowadays people from municipal solid waste, they will burn this municipal solid waste in incineration tank. Then at high temperature, you will get some ash particle. People are nowadays also working with those incineration acids also. It will have a composition of all those solid waste. Okay, I can say several examples with respect to this pozzolanic material. As this material involving in a lot factor in the rheological of cement paste, that is, it will increase the kinematic viscosity of your cement paste, thereby increasing the setting time, and you can have a lot of workable space. That is, you can, for example, if you take like a PPC cement with a higher amount of fly ash thing, the setting time is higher, which means that the transportation of your wherever you make your concrete thing, which is transported to on-site or construction, it will take, you can go for that longer period if you introduce pozzolanic material. And also the advantage is it will have some percentage of carbon content, hence it will having a automatically resistance towards acid attack and sulfate attack. Those are the advantages coming along with this pozzolanic material. Sometimes the role of pozzolanic material is should be defined. For example, if you take so much finer material of pozzolanic material that is lesser than 1 or 2 micron, what will happen is it will play as a filler material. I think you know the meaning of filler. It will fill the small void space in between or the space available in matrix, where it will fill those space, thereby increasing the density of material and contributing to the both mechanical and durability performance of the cement or mortar thing. If you want to make reactive of that material, you want to present this pozzolanic material with appropriate size. If it is of slightly higher size, you can go and make it as a higher size. If the size is somewhat around 10 micron thing, and the surface is ready to react, hence the role is different now. Okay. Sometimes if you go for a higher size, that is almost around 25 micron thing, the pozzolanic materials coming into nature as a inert material. Inert is nothing but it will simply occupy the space. It will absorb sometimes water, large amount of water content, thereby increasing the workability. It have a slightly different role. Okay. Hence, the role of pozzolanic material varies depending upon the size we are introducing in your cement matrix system. Okay. And then, in order to enhance the processing technique, in order to enhance the property of pozzolanic material, there are several processing techniques available in literatures. I will say several processing techniques here. If you look into literature, it is broadly classified into 3 types. That is mechanical processing, chemical processing, and mechanochemical processing thing. Then apart from this, you can enhance or improve the property of pozzolanic material by curing method also. Okay. The mechanical processing is probably divided into 3 types. That is sieving, burning, and grinding. Here on first sieving thing, what we will do is, for example, if you take fly ash or whatever material in our laboratory while you are doing your experiment, ask your student or scholar to first sieve and remove all particles which are having a higher size, that is greater than 90 micron or 75 micron. If it is greater than 75 micron, yes, I already indicated that if the micron, if particle size is greater than 75 micron, the hydration of that particular particle is not fully hydrated. Okay, it is only partially hydrated. Hence, you want to remove the particle which are larger size. Okay, then if the particle is in between above 50 to 75 micron, you want to reduce that particle size. This particle size can be reduced either by grinding or by burning. Grinding is nothing but I will introduce this our supplementary cementitious material or mineral admixture into your our pozzolanic material, sorry, into your grinding thing, that is a ball mill. Here the ball mill is nothing but I will show or I will discuss a case study where I had done my research with respect to these techniques. How I reduce this grinding and burning thing. Grinding, you can achieve this grinding using ball mill. This ball mill can be of several types, that is centrifugal, or it may be rotatory type, or it may be some other type also, or combination of types. Inclined types also available there, where there is a small different types of different diameters of balls are there, where you introduce this your supplementary cementitious material in that ball mill, and you will grind your pozzolanic material along with balls, where particles from where your sublimated cementitious material or your pozzolanic material come into contact with those different size of balls, and it is breaking into smaller sizes. Sometimes the accumulation of these particles are happening. In that type, we will introduce some surfactants. Okay, zeolite like surfactants are introduced, where these smaller size particles couldn't bind each other due to this negative cation thing and some other thing. It can be reduced when we introduce surfactants, but most of cases, if you are not going particle size of not below nanoparticle size, so this thing will be happening in very less amount. Hence, there is no need of those surfactant things. But if you want to reduce the particle approximately around 5 micron to 15 micron thing, normal ball mill is enough. Okay. Then burning is nothing but by using a muffle furnace, we will burn whatever the content of ashes we are having, we will reburn it. Okay, if you make a reburn those ashes, what will happen is it will become again a calcination of your material inside this pozzolanic material happens, and it will automatically reduce your size of particle, and then thereby make your surface of particle which is ready to react. Okay, that is the thing happening in burning. Then I can simply say that these three things, that is sieving is separation of particle, grinding is breaking of particles, burning is calcination of particles. Okay, chemical processing, second thing, chemical processing, that is two type of activation is available in literature. One is acid activation and alkali activation. Several acid activations are well known, that is people are introducing several acid like HCl thing, but it is not purely more acidic in nature. Okay, slightly acidic in nature. They will introduce those things there, but most of people will recommend this alkali activation. The alkali materials like sulfate, NaOH, sodium hydroxide, even calcium chloride can be introduced apart from alkali activation. Lime activation is available, sodium silicate, quicklime, those things are some activation thing process. And this alkali activation thing, a very good example for this alkali activation thing is this geopolymer concrete. I think you know what is meaning of geopolymer concrete. The concrete which is made without any cement. One of the good example for activating pozzolanic material using alkali activators or geopolymer concrete, that is using sodium silicate and sodium hydroxide or potassium hydroxide is used to activate, and the formation of the components which are similar to calcium silicate hydrate, that is sodium silicate hydrate or potassium silicate hydrate is formed in more compound. Those silicates or hydrated compounds are similar to calcium silicate hydrate. Okay, the binding properties are similar to this calcium silicate hydrate thing. Mechanochemical processing is nothing but this is the one thing what we call it as hybrid thing. People nowadays working with this mechanochemical processing in a large amount, since it is this is upcoming feature in enhancing the property of concrete, thereby reducing the energy consumption associated with this processing technique. They what they will do is initially either they will go for burning, and then they go for finally grinding, or else initially they go for grinding and then they will go for burning. They will do the combination of this mechanochemical processing. Okay, within mechanical they will make a combination, or with the help of chemical and mechanical they will make a combination. Okay, after reducing the size they introduce alkali activators. That is also possible with the help of this mechanochemical combination thing. Finally, the curing methods. The curing methods, that is lime curing. I think, as you know, your pozzolanic material is rich in calcium, sorry, rich in silica or alumina content. If you supply additional lime during curing thing, what will happen is again the formation of additional calcium silicate hydrate is increased, thereby enhancing the property of your concrete thing. Then elevated temperature, what will happen to this elevated temperature curing is nothing but your supply of hydroxyl ion is more frequent. The availability of hydroxyl ion across your mix is uniform. Hence, there is more. Hence, there is a more chance of formation of additional calcium silicate hydrate when you go for elevated temperature. Whereas in steam curing, you are supplying this hydroxyl ion throughout your system equally, where you can get hydroxyl ion uniformly throughout your concrete system. Whereas in moist curing, what will happen is it is producing somewhat lesser amount of enhancement, additional whatever we do normal thing. That's what we call it as a moist curing. Then processing technique, as you know, physiochemical activation combination thing, where low temperature calcination can be happened. That is chemical components and mineral structure changes by adding some limestone and some agent like, as I said, surfactant agents, followed by calcination and quenching. Quenching is nothing but sudden cooling of your pozzolanic material, what we call it as a quenching. This term is probably mostly used in steel. They introduced here. Reason is that they want to reduce the energy consumption. Hence, they introduced this low temperature calcination technique. The thermal activation, blending of lime and ash in certain proportion, they will make it in autoclave, and the temperature followed by dehydration and cooling thing. If you have new kind of material on behalf of this ash, fuel ash, you can supply those ash there so that you can activate thermally your material. Then hydrothermal activation is nothing but internal diffusion at initial stage and chemical reaction at later stage. Pozzolana is initially mixed with sodium hydroxide solution and it is heated. Then we will make separation of this alkaline and the activated sample, which will increase your property of concrete. First, we will go to discuss about mechanical processing, that is grinding thing. I will concentrate, as I said, more about this mechanical processing. Grounding the material using various types of mills available in market. As I said earlier, for example, you can go for centrifugal ball mill or a rotatory ball mill, or there is an impact ball mill also available in market. You can recommend any type of material. If you take one of the experiment Los Angeles test, what we are using, that is the best example for your rotary type of ball mill. We will introduce your pozzolanic material where already having sort of balls, steel balls are there. If you introduce there, these balls are coming into contact with your pozzolanic material, then it will try to break your pozzolanic material into smaller size, and also it will make available of more amount of surface. That is lesser the surface. If you reduce the size of particle, it will increase the surface area of particle. That is, more surface is available to react. Okay, that's what we call as a surface area, which is generally recommended in meter square per kg. If you take cement, and approximately it is 3,500 meter square per kg, you can observe it. The factors affecting the output of grinding are your grinding media. That is, on grinding media, what type of ball you are using, what kind of material it is made of, and what is the size of your ball, what is the size of shape of your material you are using. It goes on like that. If you go for grinding time, again, if you vary, several authors recommended from 8 minutes to 120 minutes. Several times, if you go for higher grinding time, you can get a same output as in medium thing. Okay, those things will happen if you make alter in grinding time. And grinding aids, as I said earlier, several literature says that they will introduce several type of surface reactants in order to avoid attracting a smaller particle one another, and also increasing the efficiency of output. They introduce this grinding aids, grinding material. What kind of grinding material you introduce inside it? For example, if you go for larger size of material, which is easily broken, but if you introduce a combination of different sizes of particle inside your ball mill, what will happen is depending upon size of particle, one particle came into contact with another particle along with your ball impact, it can break easily. Okay, thereby we can reduce the consumption of energy and also increase the output of product. Okay, ratio of grinding media to grinding material, sometimes most of literature says that 10 to 1%, that is, if you use grinding media, let's say at 10, grinding material should be of 1. That ratio they are using. Even 5 to 1 is used. Again, that depend upon type of ball mill we are using. Then ratio of grinding volume to grinding material, These grinding materials include both grinding media and grinding material here. The grinding volume is internal volume of your ball mill. Then RPM, rotation per minute of your ball mill, how it is rotating. Then feeding particle sizes, as I said earlier, that grinding material efficiency, depending upon size of specific gravity of your material, size of material, shape of material, it will affect your output of grinding. Hence, if you if you concentrate more amount on these all factors, you will increase your size of your particle and shape, size and surface morphology of particle more efficient one. Okay. Even what are the outputs checked during this grinding process or this particle size. Smaller the particle size, as I said, there is a more surfaces available to react with outer environment. Hence, what we call it as the surface area. Particle size is associated with the surface area. If particle size is smaller, surface area is more. Okay, morphological area and the surface texture. If you see morphological area, I will show an example on later upcoming. As I said already, I will show some case study with respect to these things. Okay, how the pore distribution, what will be the size of pore, how it is reduced, whether any failure surface in morphological of particle, those things can be understand. Okay. Then fineness, you know how much it is reduced. Then broken particle size, how it is broken. Then chemical composition, even exposed area are exposed during this grinding process. That makes exposure of several chemical, mineralogical composition is exposed to react. Then how the different particle size are distributed. As I already informed or mentioned, that size of particle plays a vital role with respect to increasing the density of your system it is present. Okay. Then burning process, burning the material either in controlled or uncontrolled atmospheric condition, which will make increasing the efficiency of your material. Okay. If you make burning in controlled atmospheric condition, it will yield better result. The factors which are governing this burning process are burning temperature, burning time, burning condition, and even feeding particles. What size of particle you are feeding inside this burning chamber, that plays a vital role in controlling the size of your particles. The output checked during this burning process again: particle size, surface area, morphological texture, pore size, fineness, and one important thing came into picture, that is removal of unwanted materials. That is how much amount of carbon content is removed. That can be mentioned, that can be identified with the help of this burning. Then chemical composition and particle size distribution of your pozzolanic material. Then sieving thing, there are two types of sieving is available. As you know, one is wet and dry. We will go always for a dry process. Use pre-treatment process for larger particle size. As I already said, whenever you are doing your research, kindly go and sieve your pozzolanic material, whatever you are purchasing from your market, and identify what is the different size of particle available there. Whether you, by pre-sieving thing, you can identify what is the larger particle size, whether any processing technique is required or not. Those things you can identify using those pre-treatment process itself. Here, what I try to mention is pre-treatment is required for larger particles alone. How to reduce that larger particle, that depend upon your physical and chemical processing. And the factors affecting this sieving are time, particle size, particle shape, and volume. Then chemical processing activation, acid activation. Of using a recycled aggregate, that is surface treatment. The surface treatment which will help if you introduce acid environment, what will happen is the already available cement paste around your aggregates, or that is recycled aggregate, can be removed. It will expose the area where it is having not that mortar, old mortar is present. Hence, the acid activation is highly recommended in the case of your recycled aggregates are available. In alkaline activation, you can see alkaline reagents like sodium silicate solution, sodium hydroxide, calcium hydroxide, potassium hydroxide are recommended by several researchers. and alkaline salts are available in market. If you combine this thing one day before, you can have this alkaline solution where you can make a cement with your pozzolanic material having a similar kind of your binding nature. The other solutions which are used for activation are your lime solution, cement silica fume slurry, which is again used in a recycled aggregate alone. And this silica fume slurry is used to again coat your recycled aggregate. Okay. Then calcium sulfate, sodium sulfate, potassium sulfate, those things are used to activate your pozzolanic material. And then polymer activator also available in literature. The factors affecting this chemical processing are pH, your dosage of solution, as you know, your molarity plays a vital role in making your alkaline solution. Then concentration of solution, how much 0.1 N or 0.2 N, those things also plays a vital role in activation of your pozzolanic material. Okay, I think I had covered almost major part of thing. Just give me 2 minutes. If you have any doubt across this thing, you are welcome. Hope I'm not boring this session. If you have any question, let me know, sir. Because I had covered almost what are the processing technique required. Just I can wait for 2 minutes. If you have any clarification needed regarding this processing technique, I can clarify those things. Okay, shall I continue, sir? If you have no doubt. Okay. So my screen is visible?
You can continue. We can get clarified, sir.
Okay, sir. Thank you. Thank you. Characterization techniques, the characterization of ingredients can be done. The characterization techniques, I think the speakers who are before me discussed these techniques like field emission scanning electron microscope, EDX, that is energy diffraction X-ray analysis, then Fourier transform infrared spectroscopy, in what we mentioned as FTIR, XRF, X-ray fluorescence spectroscopy, XRD, X-ray diffraction spectroscopy, and then thermal analysis using TG and TDG curve, that is thermogravimetric analysis, and derivative for thermogravimetric analysis graph, TEM, transmission emission microscope, BSC, backscattered emission electron microscope from SEM. It goes, a lot of techniques are available nowadays. There is some microscopes are available, that is what we in order to mercury intrusion spectroscopy is available in several laboratory to identify the size of pore in your concrete itself, but we are not going for such a long thing. You want to characterize your material depending upon what are the types of processing you are used. The characterization required are, you want to identify what is the specific gravity of material which is obtained output from your processing technique. Then what is the specific surface area which is obtained from output of your product from processing technique. Then what is the size of particle size distribution. If possible, go and read about your porosity of particle. What is the porosity nature? What is the volume of pores present in your pozzolanic material? What is the water absorption capacity of your material can be identified, even whether moisture content is present, and loss on ignition, which clearly indicates how much amount of carbon is present in that particular size of material, and finally density. Okay, you want to do all those things in order to identify how it is improved from its original version. Then in order to do your reactivity of pozzolane thing, I think these are the well-known tests. You can do Chappell, lime reactivity, Fratney, and lime saturation, strength activation index. Okay. we will probably do most as a strength activity test, that is will do 28 days compressive strength of controlled concrete and that of your pozzolanic material concrete and how much it is improved, which is indicated as a, in order to identify as a pozzolanic material, it will require almost as a minimum 75% of your strength at 28 days. If it is achieved, what we call it as a pozzolanic material. Okay, this is a problem, this is a maximum thing you can think in all those paper, but if you want to publish in very good journals, can you do this lime saturation, Pratney, lime reactivity, Chappell test? These are simplest test. Even you can do all those things. Okay. If you take Chappell test, which is nothing but you can take a 1 gram of calcium hydroxide with a 1 gram of pozzolane and water of 250 gram, which is boiled at 90 degrees Celsius for a temperature of almost for a timing for a 16 hours. Then a free lime content was measured by titration and fixed calcium oxide content was calculated by titrating the burette of HCl 0.1 solution using phenolphthalein as an indicator. You know this titration thing which you have done in your graduation period. And also go for lime reactivity. These tests are simple tests. You can do it in your own laboratory itself, but it will indicate some few tests indicate only titration. Okay, then here I will, as I said earlier, I will go for a case study where this thing is my research topic where I had done a processing technique for sugarcane bagaceous. Here, before entering into this topic, I want to explain what is a sugarcane bagaceous. I think everybody is well aware what is meaning of a sugarcane. The plant which we can get sugar, what we call the sugarcane. The sugar juice is obtained by crushing this canes of sugar. These crushing thing, what we waste material after extraction of juice, what we call it as a wet bagasse. This wet bagasse is dried in open atmospheric condition to obtain a dry bagasse. This dry bagasse is burned with your as per whatever the requirement available to get this sugarcane bagaceous. I obtained your sugarcane. This graph indicates original sugarcane bagaceous which obtained from industry directly. You can see a large amount of quartz and crystallobite compound which are this crystallobite compounds which indicate between 27 to 30 degree to theta angle, which indicates that this crystallobite form is crystalline in nature, where it is unreactive phase are available or seen, where quartz amounts also there. This quartz content indicates that again amorphous in nature. The burning temperature of your bagasse, this dry bagasse, which is used as a fuel for burning fuel in your sugar industry, in the industry itself for production of electricity. The burning temperature is in between some 500 to 700 degrees Celsius, which will produce this quartz and crystallite form of silica, which is crystallite indicates it is crystalline in nature, which is hard to react. This thing again I had done microscope studies for this sugarcane bagaceous. When we see this sugarcane bagaceous for the 2 micron meter using field emission scanning electron microscope, you can see a different size of pores are there. Okay, the volume of pore is different, the size of pore is different, shape of pore is different. You can see a surface texture which is somewhat spongy in nature. You can see here. Okay. The size of pore is also different. There is a thin layer in between, surface is different. Even a smaller amount of different size of particle present in this pore is also observed here. If you see a second picture, it indicates that your sugarcane bagaceous is fibrous in nature. Due to this fibrous in nature, it is looking like a thin filament thing. Okay, where a smaller amount of filament particles are attached to the surface is seen. As you see this sugarcane thing, it is again fibrous in nature, which is generally it is a fibrous in nature. Your under microscopy also it is seen as a fibrous in nature under 20 micron meter scale. If you see the prismatic shape of your sugarcane bagaceous, it is a crystalline in nature. As you observed in XRD, it is confirmed with the help of SEM, that is scanning electron microscope. You can observe the particles are crystal in shape, okay, prismatic in shape. This indicates that your particle is not reactive in nature. Even another kind of indication that your material is not reactive in nature is spongy type. Spongy type is a element itself produce some spongy in nature, which indicates that large amount of carbon content is there, which is observed with the help of EDX, that is energy dispersive spectroscopy analysis. By using that spectroscopy thing, you can observe what will be the surface, how it will be acting thing. Even you can see a silky layer around your particle is also observed there. The silky layer indicates that again your particle is covered with this silky layer, which make some part of your material to not available for reaction thing. Okay, hence you want to make such a process in to remove all those things. Even you can see a group of fibrous product also observed on this picture. You want to identify suitable process where you want to make all those particles to reactive in nature. Whatever I have said that it is in XRD, which is confirmed in FESEM, and then again it is confirmed with thermal analysis. The first graph, FTIR. This first graph indicates FTIR. In FTIR, you can see Fourier transform infrared spectroscopy. The wavelength of a different number indicates how the group of hydroxyl ions are attached to your particles. That can be identified with the help of Fourier transform infrared spectroscopy. There are two range of order of wavelength is observed. One is on shorter wavelength, another one is on larger wavelength. The shorter wavelength indicate most of silica components, that is this 820, 620 groups are associated with the hydroxyl group attached to your silica content. Okay, hence again it indicates that presence of silica, but the form is not observed here. Okay, but as you know, with the help of EDX, that is on you see back thing, and this is indicates EDX. If you see at this point where EDS analysis done, where indicates the presence of different type of elements, that is how much percentage of oxygen is present, silica is present, carbon is present. Generally, most of element is oxidizing in nature. That is, oxidation in nature. If a particle is exposed to open atmosphere content, it is ready to react with the atmosphere. It will absorb oxygen from atmosphere. It is reacting. Hence, you can see the oxygen content is more in all elements. If you see here, an object is projected. Here, an element is projected. Spectrum is projected. Where you can see more amount of silica content is observed there. Okay, and also you can see carbon content is present in some point where this indicate that this carbon whether it is preventing to react of your material. You can see the spectrum thing that more amount of aluminum and silica is present. Here also more amount of aluminum and silica is present. In spectrum you can see the CPS, counts per second. The higher amount is observed for silica alone in both the cases. That particle this indicates that the presence of silica is confirmed. Okay, it is identified and morphologically verified, and different formation is explained with help of FTR, and it is confirmed in EDX. Okay, still you needed confirm, you go for XRF. Okay, that is also done, I think. Okay, yes, in order to further confirmation thing, thermal analysis done in this original sugarcane OSCBA, nothing but original sugarcane bagaceous. Thermal analysis is done. Thermal analysis is nothing but the decomposition of your pozzolanic material at various temperature. For example, if you take a material which is burned at 100 degrees Celsius, what will be the mass loss? If it is burned at 200 degrees Celsius, what will be the mass loss? Likewise, you can measure your material up to 1400 degrees Celsius. This green curve indicate your mass change, whereas your this pink, not pink, this violet color indicates the change of this mass change per minute. Okay, that is indicated. This is a green curve is a TGA, whereas from TGA this TDG is derived. You can see there is a drastic mass change which is happening above 1000 degrees Celsius, which is indicate that the conversion of alpha Cristobalite is a nature of crystal, which is unreactive in nature. There are two different kind of conversion of this cristobalite is observed, which is observed with the help of a drastic change in mass. Okay, if you go for XRF, X-ray fluorescence spectroscopy, there are different composition of your minerals are observed here. This indicates that the larger amount of Al2O3, SiO2 is present. This indicates that this is a pozzolanic material. Large amount of silicon dioxide and aluminum oxide is present, but they are present in a unreactive form. You want to make you want to introduce several process in order to get your material as or active in nature. Now, what I had done is, initially I obtained your whatever material from industry. For example, I will take that material initially as a 5 kg. I will initially sieve it. By initially sieving it, how it will seems, and that I had observed with the help of FESEM. What I call it as coarse unburned particles. The particle which are passing through 600 micron meter and retained on 300 micron meter. What I call it as a coarse unburned particle. If the particle is passing through 300 micron and written on 150 thing, what I call it as a fine unburned particle. If particle is passing through 150 micron and written in 75 micron, I call it as partially unburned particle. The particle which is passing through 75 micron meter and written in 40 micron, I call it as a fine burned particle. If you see right side thing, you can clearly observe the images of this presence of coarse unburned particle, fine unburned particle, partially unburned particle, and fine burned particle. The presence of carbon content is drastically reduced. That is, at the initial stage itself, you can remove your large amount of carbon content by normal sieving itself. You can see using EDX analysis. EDX is sometimes called as EDS, that is energy dispersive spectroscopy alone. You can see a drastically reduction in carbon content for fine burn particles. Based upon type of size of particle itself, your particles carbon content is reduced. The simple processing technique what I had adapted is shown here. The sugarcane from sugarcane industry, I had obtained original sugarcane bagasse as received from industry. The characterization what I had done, I had shown earlier those things. Then what I started doing is I sieved this original sugarcane bagasse. Okay, the particles which are lesser than 60 micron thing, I take that particle to your classification of SCBA particles thing. Or else what I had done is, I had done this particle to pre-burn it. Pre-burn is nothing but I will burn this sugarcane bagasse in oven for 100 degrees Celsius at 24 hours. Then I will make it as a pre-ground using Los Angeles test. That equipment we use for Los Angeles test for 30 minutes. And again I go for sieving. In similar way, what I try to make is I reduce the size of particle and I classify this material as 4 types. That is 600, 300, 150, 75, and 40 micron size. Okay, then I will go for your processing thing adopted. Sorry, processing techniques. The processing technique initially what I tried is combination of your grounding burning thing. In grounding technique, what I'm trying to do is I introduce these particles to your ball mill with variation in volume of ash to volume of grinding balls, and the diameter of grinding balls are varied. The ratio of diameter of various grinding balls, that is different size of balls are used as a grinding media. A ratio of feeding material, as you know, I classified feeding material as 4 types. I varied this input material also. Ratio of volume of cylinder to grinding material, that can be also varied. That is, I fixed the volume of cylinder to grinding material as a 1:5 and 1:4. Then grinding time variation. These are the factors I make as a change in order to get an optimum result with lesser energy consumption in grounding technique itself. In order to obtain particle which are lesser than 40 micron size. If it is greater than that, I will again go for sieving process, again classified it. I will again do this grounding process repeatedly. Once the particle which are finer the 40 micron size, I will take it to burning technique, where the 2 factors only, burning temperature and burning time is as a variation thing, I done this processing technique, that is a burning technique, and I had obtained processed sugarcane bagaceous, which is lesser than 40 micron size, which is stored in airtight container, and I used it for your further replacement in months. The methodological I shown here in flow chart, I am trying to explain all those things here, and that is initially with a grinding technique. And if you see right side, the grinding balls with the different types of diameters of grinding balls are used. That is one is of 25 mm, 18 mm, and 8 mm. The diameter of balls, sorry, the type of ball is used is ceramic. Zircon ball is used for grinding thing. The grinding jar is of dia of 220 mm and height of 155 mm. Grinding time is varied between 8 to 45 minutes to get a minimum size of your minimum size of particle and appropriate particle size distribution. As to ball ratio is kept as 1:4 and 1:5. Okay. Then for burning thing, the left side muffle furnace up to a maximum temperature of 1100 degrees Celsius available in our institute is used. The ceramic crucible which can withstand up to 1000 degrees Celsius is taken as a solid jar where I can kept, which have a capacity of 300 gram is sorry, 300 gram is used to burn material obtained from this grinding process is used here for again burning. The burning temperature is varied in between 300 to 500 degrees Celsius, and burning time is varied from 2 to 5 hours. What happened is you can't kindly remember that for doing this processing technique and obtaining almost a 50 kg of your PSCBA thing, it will take almost for me 4 months. It will take 4 months since I can get a kg of cement for 2 days alone. Okay, per kg for 1 day. If I go for this burning temperature, it should be cooled. If I kept for 500 degrees Celsius, it should be cooled for minimum 3 hours so that we can handle that ceramic crucible thing. Or else you could even not touch those things. I had worked for minimum 4 months to prepare for almost 50 kg of cement. Kindly remember the time taken for this thing. You can also go for several machine learning process to make optimization of all those things, which is good for your publication also. Burning of SCB at high temperature causes the conversion of amorphous silica to crystalline silica. Earlier in grinding process, what will happen is the particle size is reduced, whereas in burning process, the nature of crystal structure is changed. The parametric studies on optimization of particle size is shown in this tabular column, where the parametric considered for particle size are feeding particle size, the variation in feeding particle size, then grinding time variation, as to ball variation, feeding material to volume of grinding jar, as I said, 1:7 is introduced here, then diameter of ball size. Single ball is used, 2 ball uses, and 3 balls are used. How many number of trials are used in each process, and the particle passing through 40 microns, you can see there is a gradual increase in particle size passing through 40 micron size. Then what is the average particle size? Using particle size analyzer, we can identify the average particle size and particle size distribution of those small particles. Okay, the optimum thing I had shown in last column, where what is the optimum size in each each process. Okay, then under each process, what will be the morphological change that I had observed is shown in this slide. For example, if you take SCBA to grinding ball ratio as 1:4 and 1:5 for different size of balls are shown in this picture, where you can see the maximum percentage of particle passing through 40 micron series higher for 8 mm balls with 1:5 ratio. Okay. Then again, second variation is that SCBA to grinding balls 1:4 and 1:5 for combination of two different balls. What will the particle size and what is the dia? How the surface texture is changed? That you can observe from this slide, where morphological size is reduced. And then third thing, the combination of three different balls, that is 25, 18, and 8 mm balls. Still, you can observe there is a prismatic shape of crystals of SGBA is observed in using FESEM analysis. Then feeding material ratio thing. If a ratio of 150 micron meter to 75 micron is maintained as 2.1, what will be the percentage of particle passing through 40 micron sieve? Using different proportion of particles feeding inside, that is also play a vital role in production of lesser amount of particle size. You can see the particle size is reduced. Then finally the burning temperature thing. Using burning technique, increase in temperature with increasing in time, you can see lesser amount of particle is obtained. But as a keep in mind for lesser energy consumption, the processing technique adopted is lesser temperature. That is, I kept around 400 degrees Celsius. Since 96% is obtained as maximum particle size, then you can see by a modular distribution of particle for particle size distribution is seen in first curve for different size of particles obtained from each process. That is single ball, double ball, two balls, combination of three balls, then variation in input particles, and then combination of all those things, then temperature thing. All those is shown here. Evenly particle size distribution with cumulative percentage is shown here, where you can see particle size is actually logarithmically distributed, which is helpful for producing highly packed or increasing filler effect of material. And then I had done this morphological studies again, how the structure is improved. Early you can see macro size pores in original Sugarcane bagaceous, whereas in PSEBA you can see these pore sizes which is in nano size. Then you can see crack on the surface texture or surface morphology of your particle. You can see the processing effect, that is impact of smaller particle on your fibrous particle. The broken particle sizes are shown here, and the smaller particle sizes are formed. More amount of smaller particle sizes are formed. Even fibrous particles are broken into smaller pieces, which explodes the area inside your processed Sugarcane bagaceous material. Even there is a surface crack in fibrous material with the formation of nanopores are observed. Processing effect indicates that impact of small particle on surface of your CBA is observed on left side figure, whereas on right side figure the formation of nanoparticles under 200 nanometer is observed with the help of SIM. With the help of EDS, here you can see the increasing in proportion of calcium to silica ratio at different materials once it is processed. Okay, the proportion of calcium to silica ratio is increased. Even proportion of calcium to aluminum also increased. The Fourier transform curve indicates again there is again three different curve. Earlier you can see two different wavelength is observed. One is on shorter range, another one is on longer range, whereas in here you can observe three different range, that is on higher range order above 300 centimeter inverse, and one is intermediate in between 2000 to 1500 to 3000 centimeter inverse, and one is last one is lesser, which is shorter wavelength range, which is used to determine your silica composition. X-ray fluorescence spectroscopy is used to determine your different chemical composition of your pozzolanic minerals, that is SiO2, Al2O3 and Fe2O3. You can quietly see how it is increased. Then the specific gravity of original sugarcane, as I said already, what are the factors you want to compare, that is specific gravity is increased from your original sugarcane bagaceous to processed thing. Water absorption is reduced, moisture content is reduced, bulk density is reduced, mean particle size there is a drastic increase, that is 105 to 40. Then it is blended with cement. The property of cement is shown in this slide. With increasing in your PSBA content, you can see there is an increasing in strength. I had gone for 40% of replacement of ordinary Portland cement of 53 grade. I had determined your consistency and specific gravity for PSCBA thing is shown here. I didn't show your OSCBA thing. It is since it is improved a lot. And final conclusion is that for past 5 years, almost more than 4,000 million tons of cement is produced across global, and 280 million tons are produced in India. The average contribution for average contribution of economic development of country is almost 35% coming from cement industry alone directly. There are so many other factors which is contributing to economical development which are related to this cement industry is also seen. Even if you had if you come across global and Indian scenario, the production of SCBA is almost 100 million tons and 22 million tons. So such a huge availability of SCBA is SCBA is likely to introduce as a new kind of supplementary cementitious material in the Indian market by introducing as 18th variety of cement as a bagaceous cements. Then processing techniques depend upon type of pozzolanic material whatever we are using. The processing technique will enhance the property of pozzolan, as we already discussed. These techniques should be sustainable in nature. Again, we will concentrate more about this sustainable, and we should not not only in processing of cement but also in processing of pozzolan itself. We want to make it as sustainable in nature. And then on conclusion part of sugarcane bagaceous thing, the micro characterization of original sugarcane bagaceous particles shows that particles are in unreactive form. The trial and error method was adopted to find size of particle. Mechanochemical processing is adopted to improve the property of sugarcane bagaceous. Micro characterization of PSCBA particle shows enhanced properties compared to OSCBA. Physical and chemical properties of OSCBA and PSCBA were evaluated. Even blended cement of PSCBA showed improved properties up to 30% of OPC replacement. Hence, it is viable to introduce this sugarcane bagaceous as a replacement for your cement. Thank you. Thank you all. Thank you all for your patient listening. If you have any queries, I will wait.
Participants, if you are having any queries and clarifications, you can ask Mr. Jagadisan, Dr. Jagadisan.
I think I had shown my email ID also. Thank you. Thank you for your... Yes, sir.
Sir, any clarifications? Kindly clarify with Dr. Jagadish, Professor. Otherwise, in future, if you are having any doubt, you can contact him through mails. Mail ID will be given. So you can contact in this area. If you are having any doubt, you can contact him. So if you're having no doubt or any no clarifications, we can close this session now.
Okay, sir. I will share the PPT with coordinators, sir.
Okay, thank you, Professor. Thank you.
Yeah, thank you, sir.
Okay. Thank you, Professor Dr. Jagadish, for giving a valuable lecture on enhancing pozzolanic materials, properties of pozzolanic materials by following different techniques. So in this topic, he has covered elaborately. So what are the pozzolanic materials and source of pozzolanic materials and different cement industries across the world and how quantity of cements are produced across the world and how it can utilize the pozzolanic materials for cement production and various techniques. In his research, he has done many techniques, followed many techniques to improve the properties of pozzolanic materials. He delivered a nice lecture. Thank you, Dr. Jagadish, for your nice lecture.
Thank you, sir.
So, dear participants, now the session, we close the session now. And again, the next session, third session will be started exactly at 2:15 p.m. So, you're all requested to join at 2:15 p.m. Thank you for one and all. Thank you. Thank you, sir.
Una frase de